36,000 feet below the surface of the Pacific Ocean, the concept of biology fundamentally breaks down. In the absolute freezing darkness of the Mariana Trench, the water exerts a hydrostatic pressure of 8 tons per square inch. It is the equivalent of 50 jumbo jets stacked onto the chest of a single human being. By all known laws of marine chemistry, this environment is a sterile, crushing void.
Yet, as deep-sea submersibles and acoustic multi-beam sonars began sweeping the hadal zone, they recorded something that defied the physics of the abyss. Massive, symmetrical acoustic shadows resting on the trench floor. Anomalies that closely resembled colossal rib cages and spines, dwarfing the anatomy of any known modern whale. The discovery birthed a terrifying question. What could possibly leave a skeleton that massive in the deepest place on Earth? And more importantly, how was a skeleton surviving down there at all? To understand why these deep water anomalies sent shockwaves through marine biology, you must understand the chemical boundary that governs the deep ocean. Oceanographers call it the Calcium Carbonate Compensation Depth, or the CCD. It is the snow line of the sea. In shallow, sunlit waters, the ocean is rich in dissolved minerals. Marine creatures easily extract calcium from the water to build shells, teeth, and bone. When they die, their remains sink, piling up on the seafloor as thick, white carbonate mud. But as water gets colder, deeper, and subjected to immense pressure, the chemistry violently flips. The water becomes highly corrosive. Below a boundary that averages roughly 4,000 meters in the Pacific, dissolution wins entirely. Below this depth, calcium carbonate cannot accumulate. Bone, which is made of calcium phosphate wrapped in a delicate collagen matrix, faces the exact same fate. It does not fossilize gently in the deep. It is chemically dissolved into nothing. Therefore, finding massive, intact skeletal structures sitting nearly 7 miles down in the Challenger Deep should be a metallurgical and biological impossibility. When the acoustic sweeps first detected these massive, rib-like structures, the immediate scientific assumption was a whale fall.
When a colossal cetacean, like a blue whale, dies at the surface, its carcass, weighing upwards of 160 tons, sinks into the dark. It delivers an enormous, sudden pulse of biological nutrients to a seafloor that is otherwise starved of food. But a whale fall does not remain a skeleton for long. Within months, sleeper sharks and abyssal scavengers strip the flesh. Then, a genuinely nightmarish organism moves in, Osedax, nicknamed the bone-eating zombie worm. The Osedax has no eyes, no mouth, and no stomach. Instead, it secretes a highly acidic enzyme, drilling root-like structures directly into the whale's skeleton. Using specialized bacteria living inside its roots, the worm digests the collagen and fat trapped inside the bone matrix. Under the relentless assault of Osedax and the corrosive chemistry of the CCD, an entire 100-ton whale skeleton is entirely eradicated in less than a decade. It vanishes. Whatever these massive, symmetrical anomalies on the trench floor were, they were drastically larger than a blue whale, and they were not decaying. If the structures were not the remnants of surface whales, scientists were forced to entertain a darker hypothesis: deep-sea gigantism. Gigantism is not a myth. It is one of the most strictly documented evolutionary adaptations in ocean biology. Extreme cold, lack of resources, and immense hydrostatic pressure cause certain deep-sea creatures to grow to terrifying proportions. The giant isopod, a terrifying bottom feeder, grows to nearly 3 feet long in the dark, dwarfing its finger-sized shallow water cousins. In the trenches themselves, researchers recently sequenced the DNA of Iolella gigantea, a supergiant amphipod. They discovered highly mutated genetic pathways tied to insulin signaling and cellular storage. Machinery evolved under extreme pressure to let the animal grow massive and survive for years without eating. If abyssal gigantism could scale a bottom-feeding scavenger to 10 times its normal size, what would it do to an apex predator native to the hadal zone? But as autonomous submersibles finally reached the trench floor to visually inspect the sonar anomalies, the truth they uncovered was far stranger and far more profound than an unclassified monster. The massive rib cages appearing on the acoustic sweeps were not the bones of a single creature. They were jagged, symmetrical geological fault lines, the literal stretching and tearing of the Earth's crust. However, nestled within those crushing tectonic plates, researchers in 2024 made a discovery that actually did break the laws of deep-sea chemistry. They found perfectly preserved calcium carbonate fossils, ancient plankton shells and microscopic marine organisms sitting completely intact at 10,000 meters deep, thousands of meters below the line where the ocean should have dissolved them. How did calcium survive the crush of the abyss?
The answer is planetary mechanics. These fossils are over 17 million years old. They formed in shallow, sunlit water far above the corrosive boundary of the CCD. Over tens of millions of years, they were carried downward by the excruciatingly slow subduction of the Pacific tectonic plate. They were literally dragged into the hadal zone by the Earth's crust, buried under millions of tons of rock, protecting them from the acidic water. Only recently, as the trench floor cracked open under tectonic stress, were these ancient skeletons exposed to the dark once again. The fossils did not resist the ocean's chemistry. They cheated it. They arrived from a prehistoric world, riding the crust of the Earth into the deepest graveyard on the planet.
Even now, the biology at the bottom of the world is rewriting its own rules to survive the impossible. Researchers recently discovered that a tiny organism living at the very bottom of the trench, Unidentified gigas, survives the crushing pressure by altering its own molecular chemistry. While early studies believed it coated its shell in an aluminum gel, recent advanced imaging revealed something far more complex. The creature actively enriches its exoskeleton with bromine and magnesium-substituted calcite, forging a biological armor that refuses to dissolve in the acidic dark.
The Mariana Trench is not a barren, sandy wasteland. It is an active, violent recycling engine. It drags the prehistoric remnants of a sunlit world down into absolute darkness, while the creatures native to the abyss engineer new biochemical armor just to survive the night. We have mapped less than 20% of the ocean floor. The greatest anomalies on Earth are still waiting in the dark. Subscribe to ScienceTelly as we continue to shine a cinematic light on the dark, forgotten corners of the natural world.